Okay, this is the final video. I hope you're hanging in there. So first, let's look at the problem, right? So we want a stochastic analysis, and we want to simulate 220-year trajectories with real data from the historical S&P. And what's going on here? Well, this is it. So let's say you went to your broker and you said, or your investor, and you said, hey, I want you to tell me if I'm actually going to earn money here. Like, what's the odds that if I give you my money that you're going to actually increase the value? And if the broker says to you, well, I tell you what, I'm going to do a bunch of math for you, and I'm going to show you the values, and I'm just going to make up a bunch of rates of return. And I'm going to show you that by making up those rates of return and doing math on it, I can prove to you that there's a 90% chance that you're going to make money. Well, I would tell them, oh, well, you made up the numbers. I don't trust you. Like, I don't really care what you're doing with the math. You're not using real data, right? So in this problem, we're actually using real data and the Monte Carlo simulation to say, hey, look, like this is what the S&P looked like in these. What was it in these over these 50 years? These were the real rates of return. So now, if I simulate this a whole bunch of times and I don't actually do it in the same sequence, but I actually just pulled numbers from the real data and used that in my simulation instead. So that's what is called a trajectory. So I just randomly pull 20 numbers from this table. And I say, hey, look, using real data from the S&P 500, like no matter what, there's a very strong probability that you're going to make a lot of money, and there's a very strong probability that it's going to be above a certain number. So that's essentially the question that we're trying to answer here, and so we're going to do that. So a couple of hygiene things. I set a min and a max because there are 50 years of the S&P data, so I just set our index ranges from 1 to 50. And that is because I am using the number rand between to generate a random number between 1 and 50, right? Okay. And then these tables here I copied from earlier, so there's nothing new here. We're still doing $50,000 initially. We're adding in 18,000 annual contributions. We're doing it over 20 years. Our target is $1 million, and we're going to do 200 simulations. Okay, so now, good and bad news. So good news is that the math is really easy using Excel. The bad news is you do have to copy this stuff 200 times. So when you're setting this up, just kind of keep that in mind. All right, so we're setting this up here. Something else that I wanted to kind of keep track of is, we're putting in $50,000 and then $18,000 every year. So I did actually want to keep track of how much money I actually put into it. So 410,000, because I want to answer the question like, what's the probability that I don't lose money, which is kind of pretty important. So here, we're going to roll essentially the die 20 times, and we're going to pull the real data from the S&P 500 numbers. So here, I'm using the function index. The array that I'm pulling from is this array right here between these rows. And I'm generating a random number between here, 1 and 50. So I do that 20 times, and I get these values. And I do that 200 times. So I have each one of these columns is a 20-year trajectory. And I do it 200 times. Now, how do we use these values? Well, now we start with an initial contribution of $50,000. And then each year, we start with our initial amount. We're going back to, because this is a simulation, we're going back to this equation right here. We have our first year contribution, and then we have A1 equals A0 plus the interest rate plus another contribution, plus contribution of 1. Sorry, 1. And then here we're doing A2 is equal to A1 plus contribution of 2, etc. I'm going to back these changes out so I don't ruin my nice spreadsheet presentation. But that's essentially what we're doing, is we're just doing the math the hard way. So here I have initial 50,000, and then the next year the value went up by 1 plus r, so 1 plus this value. Okay, here we go. So here we have this first number. So we started off with $50,000. And the next year we have $57,000. You might ask, hey, wait a minute. You know, we lost 20% of our numbers, but I showed growth. Well, don't forget that we added in 18,000. So we lost 20% on the 50, but we added in another 18,000, and that gives us 50,000. And interestingly enough, for this particular value, like even though the first year we dropped 20%, we had a great, nearly 2 decades after that. And our portfolio is now worth $1.47 million after putting in only $400,000. So we gained nearly $1 million under this particular simulation scenario. So each of these each of these columns here then is a year, is a simulation of a given year using this rate that we pulled from, and these are all random values. So just like the last time, I copied this 200 times over here, and you see a whole bunch of numbers, but just like in the last simulation, the only number that actually matters is this final value that I put in there. And look, I just want to show you real quick. Like, these equations aren't incredibly difficult. I'm pulling a random number from this index. That random number is some number between 1 and 50. That's it. That's all this is, repeated 20 times to get a 20-year return rate, and then 200 times for 200 simulations. I have one equation here, copied 20 times. And all I do in this last line is I just say, hey, give me this final value. Right? Builds on top of each other. It's using this formula right here. And I copied this 200 times, and that's it. That's all I had to do. That's Monte Carlo simulation right there. Now, what's really powerful is the analysis. So let's look at the analysis. I went ahead and I broke this up in between $0 and 3 million. What I actually did here is my count. I actually asked, what's the probability of a number greater than 3 million? And then what's the probability of having, going between 0 and 100? So this count here is between 0 and $100,000. This count here is between $100,000 and $2,000. This one here is above 3 million. This one here this count is between 2,500,000 and 2,600,000. And all I did is I counted. So I used count ifs, right? Because I have multiple things, and I went greater than, equal, or this number, and then less than the next number. I counted them all. That's it. I added them up. I got 200 results. Yay, that's really nifty. Then I did the same thing I did before as in the dice. I divided it by the number of simulations that I did to get my probability distribution. I added them up one after a number to get my cumulative distribution. And then I also did 1 minus the cumulative distribution to kind of help us answer out a couple of questions. So here we see the distribution. That's this column. Here we have our probability distribution. And then here's the cumulative distribution. And you can see here, sure enough, the probability of having $0 at the end of it is 0. Where's our first one? There's a 1% chance of 200,000. And then a 100% chance of earning, by the time we're at 3 million or above, we're at a 100% chance. This inverse one is interesting here. Like, what's the probability that what's the probability that I will earn $200,000? Well, 99% sure. 99% sure after putting in $410,000, you'll have $200,000 left over. What's the probability of earning $1.25 million or $1.4 million? 25% chance of getting $1.4 million. What's the probability of getting $3 million? In this particular case, it's 0, no chance. Earning $2.9 million, you have a 1% chance of doing it. And let's look over here and answer the specific questions that Dr. Tsay asked us to answer. Find the probability that our final wealth is greater than the targeted wealth. Find the 5th percentile and find the 95th percentile. So let's look at that. Okay, so the 5th percentile, hey, look at this. The percentile function. You just give it the data. So we're going to go off the original data, not the tabulated data. We go from B59 to GS59 right there. That's the range of values we gave it. And then we say, give me the 5th percentile. And boom, that number right there. And if you look at Dr. Tsay's example, it's pretty darn close to that. Remember, this is random, so every time you do it, it's a little different. The 95th percentile is $2.1 million. And does that track with our chart over here? Come over here. We're going to go find, what was it, $2.1 million. We come over here to $2.1 million. And there's 4.5% chance that you're at 2.1. That's pretty darn close to 95th percentile. Okay, so what is the probability that we earn more than $1 million? So the way we do that is we say we're going to count all the times that we were above $1 million, and we're going to divide it by the total number of simulations that we ran, which in this case was 200. And that comes back with a 52% chance. We can run it a few times. I'm just going to hit F9 to do this a bunch of times. And you can see the value bounces around a little bit. But it seems to be, there's a good 50% chance at least that we're going to earn $1 million or more. So that's not bad. There's a 25% chance that we'll earn, let's go see where's 25% chance. There's a 25% chance that we'll earn $1.5 million. Like, that's neat. So this is kind of the thing that you get from Monte Carlo, is that you get a probability distribution, and you can start asking real questions about risk. So the question isn't, will I earn more than $1 million? The question is, what's the probability of earning more than $1 million? And in a financial situation, that's a much more valuable question to answer, especially if you're doing budget planning or something. You say, hey, boss, you're asking the question of, how can I earn $1 million in 20 years? And how much money is it going to take? And I want a 50% chance that we're going to earn $1 million. Well, this Monte Carlo simulation lets you answer things like that. It turns out that for a 50% chance of this, if you put in $50,000 a year and $18,000 a year every year after that for 20 years, and you put that money into the S&P 500, there's a 50% chance that you'll earn more than $1 million, right? If you say, hey, I want a 90% chance to do that, well, then you can plug in the numbers, change the values here, and find out where there's a 90% chance that you earn $1 million. And that's what you get out of Monte Carlo simulation. Okay, one more thing that I'm going to do. I know we said we were done, but I'm going to do one more video where instead of doing this 200 times, I'm going to do it 2,000 times. And I want to show you that these curves really smooth out. So I'll be back in a moment. See you in a couple of minutes.